All right, let me share a screen so that you can see how things are organized a little bit. Okay, in the Chemistry 1 course, okay, let me get down to here. Okay, in the materials section, I don't know if I reorganized this before yesterday or whatnot, but I decided to reorganize things so that the newest stuff is at the top. So if you're looking for things for the current unit, Unit 5, it's at the top. Because this list gets to be kind of long, and as we keep going, you'll have to scroll down. So the oldest stuff's at the bottom, newest stuff's at the top now, but they still like reference materials toward the top and the link for the Zoom room. So this is the current unit. Anyway, when you click on the current unit, I also reorganized the folders so that the newest stuff is at the top too. We're trying to, the school encouraged us to put the newest stuff toward the top. So I don't know if your other teachers are doing it that way, but that's where we're trying to move to. So there's a link here for the plan for the week. The two things that I want to do today is there's this Everyday Ionic Compounds project. I want to show you how that works. It's not really that difficult, but I just want to make sure that you know what the different documents are. And the other thing you need to do is that naming compounds and writing formulas assessment. You need to finish that by today. So whenever you're on the right-hand side, whenever you're in your course, whatever page you're on the right-hand side, you should see two things. There's that naming compounds and writing formulas, which has a mix of all types of ionic compounds. It's kind of like a quiz, like an assessment about your knowledge of writing formulas and naming ionic compounds. And then down here it says Everyday Ionic Compounds Project, and that's due Thursday. So I think you know, I don't know if there was a message on your Facebook, or on your Schoology or whatnot. Thursday is going to be a school day, regular school day, no matter what. So it looks like we're going to get pretty significant amount of snow, but your teachers are not going to travel to school. We're going to teach from home, and then you're still supposed to log in on Thursday. So it's not as if this date will change or anything like that. But anyway, it says Everyday Ionic Compounds worksheet or project. You should be able to even get that done today if you want. It doesn't take that long to do. But if you were to click on that, it takes you to the assignment itself, which is actually just a link for a PowerPoint. But what you really need to do to be able to do that project and understand like what to do is in the folder for this week, there are 3 documents. One of them says Everyday Ionic Compound Assignment Directions. So this just has the general direction about what you need to do. Basically, like in your home, there are ionic compounds. There are all kinds of different ionic compounds. They're as pure substances sometimes, like like baking soda is an ionic compound. That's a pure substance. It's used for cooking. You might have table salt. That's a pure ionic compound. There's actually some other stuff mixed in with it, but then also included in all kinds of different food and medicine and cleaning products. There's all sorts of ionic compounds. There are probably on the order of hundreds of different ionic compounds in your home right now, and nearly all the common compounds that are on the list that I've assigned for different students to do are present in pretty much every home, in every apartment, like all over the place. So the Everyday Ionic Compound slide assignment is you're assigned an ionic compound. They're just randomly assigned, and you just create one slide. There's a PowerPoint slide that is in the OneDrive. You complete that one slide, and then I'm going to assemble them as one presentation, and then you can go through and look at everybody else's. So you want the name of the compound, which is what I give you, what's the chemical formula, and what's the common name. So for instance, sodium chloride is commonly called table salt or just salt, or sodium bicarbonate is just commonly called baking soda. So what's the common name? If you just Google the name of the compound, it'll take you maybe to like a Wikipedia page or some other kind of resource that says, oh, sodium bicarbonate, well, that's actually called baking soda, and here's common uses. For all of them, they should all have some kind of common name you've heard, or maybe like like one of them is an anti-caking agent that's used in food production. So what I mean by an anti-caking agent is, like, if you're making a macaroni and cheese, you buy Kraft macaroni and cheese, and there's the packet of cheese mix. When you open that up, you want it to be like all separate and kind of powdery. So an anti-caking agent is put in order to keep all that powder all separate, and so it's powdery. Without the anti-caking agent, the macaroni and cheese package, when you open it up, could be like one solid chunk of like a block of cheese, and that would be disgusting. So you don't want that to happen. So different compounds are added, and they're safe for you, and they're okay, and oftentimes they're good in your diet. So for instance, like you might even see that you know, the anti-caking agent used in macaroni and cheese, the cheese mix, may be a calcium compound. And as a result of that calcium salt, and you ingest it, which is absolutely totally safe, it actually increases your calcium intake, which is good for you. So oftentimes the different compounds that are added as ingredients, if you read ingredient lists, they not only have a practical purpose, but they also can have a positive nutritional use as well. Anyway, so what's the common name? What's it commonly used for? What kind of foods or household items is it in? And are there any health risks? So the thing about health risks or particular health benefits, sometimes things actually do have a health risk. And what you might read is that, like, if you take too much of it, it could be risky. So for instance, like regular table salt, you have to have salt in your diet. It is necessary for you to intake salt. All animals must ingest salt, and you get plenty of salt in your diet that you don't, like, you know, crave it. But there's a lot of wildlife that on a daily basis, they're constantly looking for salt sources. And you might know, like, if you're a hunter or you know hunters, they one way to attract deer to a location is to put out a salt lick, like a block of salt, and deer will be attracted to that because they're like, yo, this is free and easy salt to get. So one thing you might read about all of these compounds is that they are maybe important and safe at some level, but then they could be toxic at another level. For instance, you need regular salt in your diet, but if you were to like eat 5 pounds of salt, not only would that be disgusting, but that could kill you. That could be enough to upset the balance of ions in your bodies to cause you to die. So like you might know that if you're out on a ship and you run out of water and the only water to drink is salt water, if you drink salt water, not that drinking salt water itself is deadly, but it will be a diuretic. So sometimes, and this is a thing you can include, some things have health benefits or they're necessary, but everything is toxic to some level. Meaning, like, in small amounts, you might need it. In large amounts, it could be bad. So what health risks or health benefits are there with different levels? Anyway, so you put it all on one slide. In that folder, that's the directions, but that's also included on the slide thing itself, where it says Everyday Ionic Compound, Assigned Compound. You click on that, and it's a little PDF, and I didn't like play favorites or anything like that. I just made a list of common compounds and then just stuck them beside the class list in alphabetical order. That way we just kind of divvy them up. One of the other teachers who's doing this project is just like saying, okay, here's a list of stuff, just pick one and do it. But then we might end up with like a bunch of one and some of the other. So just find your name, and right beside there's the name of a compound. And those are all ionic compounds that you know how to write the name of now, or now know how to write the formula of them, but you can find out like where they happen to be. Okay, so anyway, this is the directions. That's the compound you're assigned. When you click on the Ionic Compound project itself, all that it is a single PowerPoint slide in OneDrive. And so when you open that up, oops, I got to sign into an account. Whenever you open the OneDrive up, it'll just open up a single slide, and it's sort of like a template, but not really a template. Whenever it opens up, it kind of has that basic information. So you can just replace this stuff. You just name of the chemical, put the formula, what's the common name, what's it used for, what's it found in, and what kind of benefits or health risks are associated with it. And you can make the thing look good. You can add pictures to it. You can change the background. Don't make it like too funky or whatever. But once you complete the individual slide, then you just hit submit and it'll be done. And then I'll collect them all and put them into one, and then you'll be able to look through and see everybody else's, and then learn about the common uses for all those different ionic compounds. Okay, so that's the deal. What you need to just focus on today is, if you haven't done the naming compound and writing formula thing, you need to do that like by tonight, and you can work on the Everyday Ionic Compound project. This has the directions, this has the one that you're assigned to do, and then that's the one where you complete the assignment. Okay, for the rest of the class period, I will take questions about and help you with any kind of problems that you have about writing formulas for or naming different kinds of ionic compounds. If there's a particular set of problems that you needed help with, I can answer questions about that. And so if you don't have any questions and you feel comfortable and know what you're doing, then you can leave the Zoom and work on the stuff. I will stay here for the remainder of the period. So if you want to come back in and you have questions or you have trouble with something, then that's totally cool. But if you have questions, you can put them in the chat. You can turn on your mic. Let me know which kind of problems you have issues with, and I can help you out. So if you're good, see you tomorrow. But if you need help, just let me know what kind of things you need help with. Let me make sure my sound is still working. Just give me 1 second. Looks like, I don't know why the power's off on this speaker. Let me try one more time.
The side of the road.
Okay, there it goes. Sorry about that. I had to check on that thing. Okay. Like charges and that kind of stuff. Yeah, okay, so let me go over like some basics of stuff real quick. I can just make up a couple examples here. Let me copy a page. Open board. All right, give me 1 second. Okay, I can give you like a couple different examples of some different ideas. So like from the periodic table itself, all of the elements that are in group 1, all the alkali metals, when those elements form ions, they all have a charge of 1+. So you'll see this is a kind of a specialized periodic table with just with charges. All the alkali earth metals have a charge of 2+. Then over here on the right hand side, well, all the noble gases, they never form ions. But the halogens all form a charge of 1 minus. These are called the chalcogens, or the oxygen group, have a charge of 2 minus. All these elements generally have a charge of 3 minus. And then really the only other compounds that form ionic compounds with a positive charge are over here, and these have a charge of 3 plus. So from the left-hand side going to the right, from the S and the P section, it's 1 plus, 2 plus, and then 3 plus. And then going from the right-hand side to the left, 1 minus, 2 minus, 3 minus. The transition metals can have different numbers of charge. So all these transition metals can have like multiple charges. Like, so for instance, there's iron 2 and there's iron 3, like right here and whatnot. Besides the elements on the periodic table, there's also these polyatomic ions. And every ionic compound is always formed between one cation and one anion. So a cation has a positive charge and an anion has a negative charge. Every ionic compound is one cation and one anion. There might be more than one of each, but there's one type of cation, one type of anion. So the simplest kind of ionic compound is one that's formed between a metal on the left-hand side of the periodic table and a non-metal on the right-hand side of the periodic table. If they happen to have the same charge, you only need one of each. So, for instance, if you have like potassium and bromine, because potassium has a charge of 1 plus and bromine has a charge of 1 minus, compound with potassium and bromine, the compound needs to be neutral. So KBr would be the formula, because you only need one potassium for each bromine. For every one positive charge, you need a negative charge. If instead it were to be like, I don't know, like calcium and bromine, if it's calcium with a charge of 2 plus and bromine with a charge of 1 minus, if you only had one bromine for every one calcium, then the compound would still have a positive charge. In order for it to be neutral, you need as much positive charge as you have negative charge. If calcium has a charge of 2 plus and each bromine has a charge of 1 minus, you'd need 2 bromines to go with every calcium. So like CaBr2, and this would be calcium bromide. That method is also called, people call it the crossover method or the cross-down method, because whatever the charge for calcium is how many bromines you need, and whatever the charge for bromine is, that's how many calciums you need. So the simplest kind of ionic compound is when you have a cation from the left-hand side and an anion from the right-hand side of the periodic table. I mean, another way that you can have an ionic compound is with when there's a polyatomic anion. So this whole chart here has polyatomic anions. They're called polyatomic because poly means many. So each, or two or more really. In this case, you could have an anion that's made up of 2 or more elements, but the charges are listed. So maybe you have a compound that's formed between magnesium and phosphate. This is a cation with a positive charge, and everything on this chart is actually an anion with the exception of ammonium, which is a polyatomic cation. So maybe you have a compound that's formed with magnesium, which has a charge of 2 plus, and phosphate with a charge of 3 minus. In order for that compound to be neutral, you'd need 3 magnesiums to go with every phosphate, or the charge for the phosphate is the number of magnesiums, the charge for the magnesium is the number of phosphates. And the compound formula would be Mg3, and if it's a polyatomic ion and you need 2 or more of them, then it has to go inside a parenthesis, PO4, 2. So that would be the way in which magnesium phosphate's formula is written. There's only one type of compound with a polyatomic cation, and that's if it's ammonium. So like if it has a polyatomic cation, it could be ammonium, NH4, which has a charge of 1+, and maybe sulfide. So sulfide has a charge of 2-. If it's ammonium sulfide, you need 2 ammoniums to go with every 1 sulfide. So it'd be NH4 2S, because you need 2 ammoniums, each with a charge of 1+, to balance out the sulfide with a charge of 2-. And then the only other type, well, there's 2 other types then. There can be types with transition metals and ionic compounds with transition metals. If there are 2 or more different possible charges, so maybe it's copper 2 chloride. So if we write copper 2 chloride, because there are 2 different forms of copper, copper 2 means that it's copper with a charge of 2. That's all that the number in Roman numerals means. And then chloride is right here, that's Cl1-. The formula is CuCl2. And then the other type of compound is if it's an ionic compound with a hydrate. So like, well, the demonstration I did yesterday, and that demonstration's in the video, was with what was it? What did I use? Copper 2 sulfate? Yeah. Copper 2 sulfate pentahydrate. The sulfate anion is SO4. So if it's copper 2 sulfate, it must have just been CuSO4. And then the pentahydrate, we put a dot, write what the Greek prefix is for that number. Penta goes with 5. So it's 5H2O. The hydrate is always like an H2O group at the end. So I mean, in general, every ionic compound has to be something that's positive and something that's negative. And when you write the formula must be so that it ends up with an overall neutral charge. Let's see, charges and that kind of stuff with naming. Yeah, and the names, let's see, I can write the names for some of these too. I know I kind of put a lot of stuff on one screen, but all the time, if it's an element like bromine as the anion, you just change it to bromide. So KBr is, I guess I can write it up here, potassium bromide, BROMIDE, and this would be calcium bromide. When it's a polyatomic anion, you just use the name that's beside it. So MgPO4, the cation's name is always just whatever the name of the metal is. So that's just magnesium, and the PO4, that's phosphate. This NH4 and S, 2-, NH4 and S. NH4 is ammonium, so that's ammonium, and S is from sulfide. So that's the element sulfur, but you change the end of the name to end with ide if it's a monatomic anion. And I already wrote like how copper 2 chloride would go, copper 2 sulfate pentahydrate. So the clues to tell like which type of compound it is if it's a really simple ionic compound, there's only going to be 2 different elements, like calcium and bromine, and that's it. So 1 of each element. If it uses a polyatomic ion, there's going to be 3 or more elements in the compound altogether, like magnesium, phosphorus, oxygen. Every time you have a capital letter, that's a new element. Same thing here with ammonium sulfide, N, H, and S. This compound's made of nitrogen, hydrogen, and sulfur atoms. And then to tell if it's a transition metal, those are always going to have those Roman numerals. There are a couple exceptions. There are a lot of exceptions in chemistry. Like, although silver is a transition metal, because there's only one common ion that it forms, we don't put a Roman numeral 1 after it. We just call it silver. Same with like zinc and cadmium. Those are pretty common. Rhodium, technetium, molybdenum, zirconium, yttrium, scandium. Those are kind of unusual and sort of rare, so you wouldn't really have to worry about those. Really, the only common transition metals that have only one charge are like zinc, cadmium, and silver, and honestly, not even really cadmium. Mostly just like zinc and silver. Cadmium is a relatively dangerous heavy metal. I don't know, does that help? Okay. All right, any other specific questions about problems?
That helps a lot, thank you. Thank you, Mr. Flint.
In each class we've had each class we've had ever since we've been remote, every class is recorded, and there's a link to every class recording on the plan for the week. They're all on my YouTube page. They're not all available just by looking on YouTube on the list. Most of them you have to get to the video by clicking the link, because they're actually unlisted on my YouTube page. So in other words, when you look at the list of videos, the only videos that are listed are the ones that I've decided to make public. But every class is recorded. So whenever you go into the plan for the week, I'll show you what I mean. I've now included to say also the recordings. So like you can even see what the topic was for each of the days. If you're in like, like Unit 5, and maybe it's like, from last week, and in the plan for the week about naming and writing formulas for ionic compounds, it'll say like, oh yeah, writing formulas and names for ionic compounds, and these are the practice ones. When you click on Zoom recording, it'll take you right to the YouTube page that's exactly for that day's class. And it kind of might be quick to scrub through the thing to see the examples. So let's see. All right, this is being slow. So there were examples that I did in class on that day, and this is like a list of simple ionic compounds, and we found the elements on the periodic table and wrote the formulas. And then similarly, there's a list of equations, and we wrote the names of the compounds based upon the chemical formula. So I don't know, first I listed like all the metals, just the straight up names of the metals from the periodic table that are listed first, and then show how you change the end of the name. So every single day, they're all here. I mean, this is absolutely the first school year ever that, if it's after class and it's another day and you weren't sure or didn't get what happened in class, I mean, there's a recording of class. I have never, ever recorded any classes that I've ever taught. But this year I've recorded every single class, and they're all on the YouTube page. Each of the link for each day takes you there. So like Thursday, December 10th, we went over the polyatomic ion compound practice. This was the day that we worked on naming them. There are the notes and references for polyatomic ion charts. So the best way to review or learn stuff from previous topics is to go to those. So in some ways, yeah, this school year, not the greatest school year ever, right? But it's the first school year ever that you've had access to everything that's ever happened in class. So if you ever miss class, you can do it. Still do the homework? Yep. I mean, just do your best. You'll learn as we go, right? Okay, other questions about problems?
As of now, Mr. Flint, I think I'm good. That helped cover quite a bit. Just wanted to say thank you. That did help.
Okay, cool. Yeah, anything else you need, just holla. I'll do my best.
All right, thank you. Thank you. Hope you get some snow.
All right, so that's the end of second. We're on the third now.